So yes, as we have seen the velocity time relation with the equation v is equals to u plus at. So in the same manner, we are having the relation between position and time also. Yes, these equations are very important, students, because according to these two equations, you can even find any kind of relation, any kind of measurements. If any problem is given to you, with these equations you can find anything. Okay, so here position time relation gives you an idea of the distance, how much distance is covered in a particular journey or particular event. Okay, so according to that, we are also having this same graph that we have covered in earlier part. Okay, so here is having the same values, that is OA and DC, both are parallel, and AD and OC both are parallel lines again. Okay, and the initial position, initial velocity for this graph is u, that we are not going to start from zero, we are going to start our body with particular velocity, and the initial velocity will be given as u value. Okay, so here moving forward, we are having, let us assume that s is equals to distance traveled, t is time here, and a is the uniform acceleration. Okay, mark my word, students, all these things we are reading right now, all these are considered for uniform acceleration only, because you can see the slope in the graph is straight line. Okay, we are not considering here for non-uniform acceleration. Okay, so here, so distance traveled by the object in a given area enclosed with the OABC is the graph. Yes, definitely one trick I may tell you, students, whatever graph you are going to have in these topics, in these chapter, so all graphs, the area beneath the graph always tell you the distance traveled. Okay, so here also we are having the distance travel. If we want to find the distance travel in this part, we need to find the area swapped by the slope here. Okay, so we can say that S is equals to OABC because the area swapped below the slope is OABC. Yes, with the particular diagram we have shown you earlier with the same thing only. Okay, so distance traveled here S is equals to OABC. Okay, so now that OABC is actually can be divided into area of rectangle and the area of triangle. Okay, that like this we have already divided it like this now, OABC, right? And here this part is considered as E, that is the final velocity. So this slope area can be divided into two parts. One is triangle and another one is rectangle. Yes, of course, that makes this slope easier to calculate, right? If we divide it into two parts, we can easily calculate the area for the triangle and the area of the rectangle, and I think you people are very grown enough that you can calculate the area by yourself also. Okay, so now see the area of rectangle here, OADC, will gives you length multiplied by breadth, that is OA multiplied by OC, and the area of triangle ABC here. Okay, so that will give you an idea of half, that is half base into height, that is our formula for the half base multiplied by height. This is the area formula for the triangle. Okay, so AD and BD, yes, base is considered to this and this one this. Okay, so here substituting OA is equals to U and OC is equals to AD is equals to T and BD is equals to AT. Yes, we can substitute because OA is considered as U only, because we have already introduced you that A is the initial position and initial velocity is U, and OC is equals to AD, that is the time part, so it is considered as T again, and BD, that is your AT part, and earlier we have already proved it as BD, that was the V minus U, and it comes as AT part. Right now, okay, so here we get again S is equals to UT plus half AT square, substituting the multiplication part of the area of rectangle and the area part of the triangle also. So you will get UT plus half AT square, okay, like this. So your final equation comes out for the position time relation will be S is equals to UT plus half AT square.